All right. Hello, everyone, and welcome to the stream. I hope everybody is doing well tonight. We are going to pick up where we left off on the last stream, although I have a couple of updates to go over. Before we do that, I do just want to take a quick second just to thank the supporters of the channel, beginning with our elite partner, Javier Lazaron, followed by our partners, Go Bullies Inc. and Matt Alsgaard. They are the top tiers of subscription over on YouTube memberships and Patreon, followed by all the other supporters you see listed here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated, and it helps me cover the cost of hosting this channel, things like hosting fees, software licenses, stuff of that nature. That is greatly appreciated, and I would also be remiss if I did not give a big thank you to all of you guys, the viewers, whether you're catching us here on the YouTube side, the Twitch side, or if you're catching the VOD after the fact. Whether you're live or watching the VOD after the fact, I appreciate you guys, each and every one of you. Without you guys, this project and thus this channel would not exist, so thank you very much for being here. Spiro, you are indeed first on both sides. Congrats on that. Luna, you get a heart as well. First three people get hearts. All right. As far as where we left off last time, we were kind of wrapping up the asset import stuff, and I think we're pretty much done with that, at least as much as I'm going to go over on stream. So I've gone ahead and created a PR here to get the refactor assets branch merged into 0.10. And just a quick recap of that. We changed 194 files. And yeah, we had 6,700 additions and 16,490 removals. So it's a massive reduction in code. That is definitely a good thing, and we're going to get ready to do a little bit more of that tonight. So what I'm going to do, once the browser has a chance to catch up, because this is a rather large page, or maybe it's just not going to do it at all. GitHub, hello. Really? Okay. Back button it is, I guess. I don't think I've ever seen Chrome just kind of like threw up on the page. That's awesome. I don't think I've ever seen that happen before. At least not for a GitHub page. That's a new one. Lou the Coder is second over on the YouTube side. Hello, how are you? Hamlet RPG, it's good to see you as well. Any cool plans for July 4th? Yeah, we've got some friends coming into town, so we're gonna spend some time with them, do some catching up and hanging out and having a little bit of fun offline. Wow. I don't think I've ever seen Chrome actually just hang on a page like a GitHub page like this. So that's neat. I'm just going to close that tab and pretend I didn't see it. All right. So we've already got this created, so I'm just going to go ahead and merge this. Again, we are merging into the 0.10 release. So let's go ahead and do that. And then I'm going to go ahead and delete the branch. So what this means is that now all of this code is in 0.10. And technically, as far as the to-do goes, that is all we had in the roster for 0.10. However, I'm not going to cut the version tonight because there is one other to-do that I need to do, but I don't necessarily need to do it on stream, and that is to verify that all this stuff works on Windows and Mac OS, because we did make some platform level changes there. So I'm not going to cut that release tonight, but what we're going to do is we're going to switch back to the 0.10 branch, and I'm going to start working on the next thing in line, which is removing the render graph. So we're going to take a look at that tonight. We're going to talk about what the new design is going to be, their new approach that's going to replace that. And we're going to go ahead and start implementing that tonight and stripping out the render graph from all of that. So with that, let me go ahead and just release 0.10. Oh. All right, I had some to-do changes there. I probably could have just thrown those out, frankly. Let's check out 0.10. Can't type tonight, apparently. So we're going to go ahead and pull down the updates from 0.10. And let's go ahead and do a git stash pop. Should just be the one file. And switch back to here. All right. So the approach that I'm going to take, and the reason that this file had to change actually is I actually swapped these two. So I was initially thinking about doing the scene first and then doing the render graph second. But the more I thought about that, the more I thought it would be easier to actually do it the other way around. So that's what we're actually going to go ahead and attempt tonight. So we're going to remove the render graph in favor of something that is game specific. And the reason that we're doing that is because the render graph is cool, right? It was kind of a neat exercise to go through. It is pretty flexible. It's configurable. There's a lot of benefits to it, right? But there's also the drawback of overhead. And, there's also the drawback that, it's kind of all of this generic framework for something that really the game should know anyways, right? And so between this and the scene, those are both things that the game knows how to handle and should handle on its own, right? So the concept of a render graph is cool. We're not going to use it. I'm going to go ahead and remove it. So my approach to this is going to be that I'm not going to remove the render graph out of the engine yet. I'm going to start by converting all of the projects over to use their own renderer and switch them off the render graph. And then I will remove the render graph once all of that conversion is done. So obviously the Illumina project is going to be the first one that gets that update. And then I think we'll pretty much be able to pick all of that up and just kind of drop it into the test bed. And the Overdrive project, I still have to separate out. But just so that those things are updated as well. Maget's, good to see you. Hope you're doing well. Apotham, good to see you as well. Welcome. Hope you guys are doing all right. Let's see. Lou the Coder, been working on your metal renderer, exploring instances SDF UI, sign distance field UI rendering to have rounded bordered circles. Was curious as to why your standard UI is not using that approach. So the reason we went that way is because I wanted to show kind of the classic way of doing it first. We probably, full disclosure, we probably are going to go that route or something similar in the future. It may even be something where we just, draw straight up, shapes as opposed to, relying on bitmaps or something. Yeah, I haven't really decided yet. We're probably going to develop a suite of tools to do that, to have several different sort of modes of rendering, if you will. But the standard UI for now is just kind of the old school way of doing UI using a bitmap array of an atlas, essentially. All right, so now that we are doing this, let's take a look at the app config, because the app config is what is going to have our render graph in it, right? So it has this render graphs section, right? And so what we're essentially going to do is we're going to pick the bits out of these individual render graph nodes, and we're going to, initially at least, place them into our game code. And we're going to place them into our game code as is, and hook everything up and get that working. And then we're going to sort of refactor it, clean it up a little bit, so that it makes a little bit more sense. So the current way that this works is we have this sort of frame begin, which does some pre-render sort of setup and stuff, and then we have the clear color, clear depth, stencil. Then we do the shadow pass, then we do the forward rendering pass, then we do the debug pass, the editor gizmo, the standard UI, and then we end the frame, right? And so what we're basically going to do is we're going to take these steps out of here, and we are going to replicate those in code. So if we go over to Illumina main, I have decided we're probably not going to do it in this file because that is going to make this file gigantic. So this is already 2,000 lines of code. I think we could probably do this a little bit cleaner than that, right? We can separate all the rendering stuff out of here. So if we take a look at sort of the steps of the application, we've got the boot process here. We've got the initialize process here. So neither one of those kind of line up with anything that we need to do. And then we have the update, right? So we might have some sort of hook in there in the updates. And then we have the prepare frame, which is sort of the pre-frame work or pre-rendering work for that particular frame. We're definitely going to need a hook there. And then we are going to, after that, let's see, we're doing a lot of work here, a lot of render-esque work in here as well. So we're going to try and unify and simplify some of that stuff too. And then we finally have application render frame. And this right now literally just calls render graph execute frame, right? So it basically just executes all of this. And then we go from there. So what we're going to do is we are going to create what we're going to call a game renderer, or maybe we'll call it application renderer. It doesn't really matter. It's not going to have any sort of interface or struct or anything like that that's going to follow. It's going to be up to the application to create that, right? So we could call it Illumina renderer, but it doesn't really matter what we call it. And it doesn't really matter how it's structured, so long as it has the entry points that we need from the actual application lifecycle itself. So, with that said, let's take a look at, we're going to put this in the game lib. And, whoops, I did not mean to open that. Let's see. So we have, what do we have in here? So we have systems, that's our game systems, and then we have world, right? So part of me wants to just kind of drop this file in source next to Illumina main and all that stuff. But I don't think I'm going to do that. I think I'm going to go ahead and do, let's see, renderer, I think is what I'm going to do. I'm going to create a folder called renderer, and then we're going to say Illumina renderer.h, right? And we'll copy paste that and create a C file as well. So what this file is going to have in it, obviously, is it's going to start with a pragma once. And we said we needed a couple things. So we're going to need, let's see, we're going to need a prepare frame. We're going to need a render. I guess we'll call it render frame, right? We might need an update. And then I'm thinking we're probably going to wind up having some sort of state data that we're going to have to store in the renderer. I'd like to try and avoid that as much as possible, but I think there's going to be some of it that's going to be unavoidable. So we're going to need a create and a destroy. And we're not going to have like an initialize or anything like that. We're just going to do all of our initialization rather in create. And I think that's probably all we're going to need, I believe. So obviously we're going to need something to represent what, the state of the Illumina renderer. So I think for right now, I'm debating whether I want to have this structure be public or private, if you will. Let's just define it here. We'll do a type def, and we'll say struct Illumina renderer. Okay, and as far as state, I don't actually know what we need to put in it yet. We're going to have to determine that as we go. So we're going to just say U32 dummy for right now, just so we have something in that struct. Okay, so create, I think all we're going to do for that is just do return type of Illumina renderer, and then Illumina renderer create. And I don't know that we're going to need any arguments for that, so I'm just going to use void for that right now. And then destroy is going to be, actually, you know what? Let's not do it this way. Let's use a return type of Boolean, right? Just to indicate failure. And we'll do a Illumina renderer out renderer, right? We'll kind of follow the same pattern that we've used before. Destroy does not matter if it fails. So we'll say Illumina renderer destroy. And of course we'll take a pointer to an Illumina renderer. And then updates, actually a lot of these are probably going to wind up having the same kind of thing. So let's see, updates. I wonder if we should probably take frame data just in case, right? We're probably going to need other stuff besides that, but for now, and I don't know why I typed destroy here. That should be update, right? And I suppose this should probably also be a return type of Boolean, right? So if the update ever fails on this, we throw an error. Same is going to be true for prepare frame. So we'll do prepare frame, and that's also going to take frame data pointer, and then render frame is also going to take that, right? And we're probably, like I said, we're probably going to need some other things that get passed to this, but this is kind of what I'm thinking in terms of how this is going to be laid out. You know, a lot like a lot of our other things are kind of laid out. So let me think. I guess the first thing that we're going to want to do is probably come in here and, whoops. We're going to want to come in here and copy these and go to the C file. And we're going to want to include Illumina renderer, obviously. And obviously we need to convert all of these to proper functions. All right, and all we're going to do here is just do if not render out renderer rather. We'll do k error, and then we'll say function valid pointer to renderer struct is required. And we'll do function. And return false. Otherwise, we're just going to go down here and return true, right? And then we just have to do init state, right? And we'll kind of cover that later. I have Dragon. Thank you for the follow. Appreciate that. Welcome. Okay, so obviously destroy is just going to be a quick check to see if we have a renderer. And then, to do the thing, right? So that's that. And then updates, obviously is going to have some requirements as well. So if renderer, do the thing, return true, otherwise return false. Do the thing. All right, and then actually these are all going to pretty much have the same skeleton. So I'm actually just going to copy pasta this real quick. And then we'll just kind of fill in the details as we go. Thank you for the follow by Weekly Warlock. I like the name. Welcome. Okay, so we're going to kind of just step through all of these nodes one by one and extract the logic to here. And that'll also kind of tell us what state we're going to have to store in the renderer as we go. So the first thing is going to be the frame begin node. So thankfully we can actually just kind of search for the name of the node and go from there. So one of the things that we get to do away with is all of these sources and sinks logic, right? Because we don't actually need that hookup and all the wiring up of that stuff. And so thankfully that becomes pretty straightforward. So typically the life cycle of one of these render graph nodes is you have this initialize, load resources, execute, and destroy. Now, initialize and load resources, I think we can go ahead and do those in one step. I'm going to try to do those in one step. More often than not, the reason that these would have to be split is because the way that we were handling this is we were doing initialization of the render graph. It was either during application boot or initialize, I forget which, but it was really early on in the life cycle of the application. And so what we actually need to do is like post boot up when all the core systems are set up, particularly things like textures and whatnot. We need the ability to load texture resources, for example, render targets, things like that. So I believe we can actually kind of, combine those things. So we have, in this case, we don't actually have any load resources to do, right? So there's no resources to load. So all we have to worry about in this case is initialize. So we're going to start with initialize and destroy, and then we'll come back to execute. Now we can see here, if we look at node initialize, there's nothing actually here. So this isn't actually required either, but I believe the interface actually had required this, right? So that's why that's there. This is another reason that we're kind of getting rid of this, right? Is this sort of interface kind of thing. I don't really like it, right? And so all we really have is the execute for that, right? Which would be done in the middle of the frame. And then we have the destroy, and that's about it, right? So this one's pretty simple. So what we're going to do here is we're just going to copy this, and we're going to go over to this is execute, so this needs to be in render frame, right? So what we're going to do is we're going to say this is the begin frame, right? And I guess we'll go ahead and scope this off as well, just for good measure. Let's see. We have a to-do in here saying this is probably where an image layout transformation should occur instead of doing it at the render pass level. and having that worry about it. I don't know if that applies anymore, actually, but I'm going to leave it there for now. We do need to come back to that, though. I'm going to put a note here. Does the above still apply? Apply. Okay, so what this does is it essentially begins a debug label and ends a debug label. That's all this really does, right? And so this gives us a snapshot in terms of debugging, where we actually are. And if there are any operations that need to happen in between here, when we view it in RenderDoc, this is where that would show up, right? So this is kind of not really necessary to do, but I like to do it so that we've got that, that sort of view in RenderDoc when we're actually debugging. So let's go ahead and include the symbols that we need. Now we had self name here. That's not really necessary anymore. We don't have a self, right? We can just pass this a string. So we're going to say frame begin. There we go. Right, and we're just going to leave the all of this stuff intact, and then we can just say note frame begin logic here if required. Okay, so that is the frame begin stuff. We also have, we also have the render graph node destroy, which just frees the name, and then cleans up the sinks and sources. So we don't actually have anything to do further. We are done with this node, right? Pretty straightforward stuff. So the next thing that we need is the clear color and the clear depth stencil. Now there are going to be some steps for this one that I can already think of because we don't actually have the color buffer and depth buffer, right? So the way that this worked previously is the render graph itself essentially got this color buffer and depth buffer assigned to it initially. We don't have that here, so we are going to need that at some point, so we're going to have to probably add those to state, which I think makes sense. I suppose I guess that won't ever really change, right? So let's go to clear color, right? We're just going to go straight to the C file. And let's see. So if we take a look at the render graph node create, we've got some configuration here for it. I don't think all this configuration is for the sinks and sources. So I don't think we're going to have a lot to actually extract out of this. I think a lot of this code is going to go away as well. Let me catch up with comments here. So the question is, what's the reason to remove it? Well, one of those reasons is all this, right? So we have, I got thinking about it, and the render graph is pretty neat, right? It allows you to kind of build a configuration like this, where you can just kind of configure something in a file, or maybe even a node editor or something fancy like that. But the drawback to it is there's all kinds of overhead associated with that, right? So we've got to deserialize this configuration. We have this concept of sources and sinks that has to be processed. And there's stuff that has to be processed every single frame. The render graph itself, with its sort of generic interface, also has overhead, right? And there's lots of levels of indirection and lots of extra copies of data being passed around and all kinds of stuff like that. And so, complexity of code is a big one. And then also, just the actual overhead of it, right? And so when you really think about what a render graph is doing, it's kind of allowing you to spell out what the application needs in terms of rendering. The problem with that is if you don't have render graph nodes that work exactly the way that you need them to, you have to create a new node, which makes it a little bit less flexible, right? If you want to change the rendering pipeline, you've got to make a new render graph node for that. Whereas the actual end application, whether it be the game or the editor or what have you, typically knows not typically, it definitely knows the type of data it's dealing with, the type of things that have to be rendered in what order, how to put the data together to prepare for the rendering. It knows all of that stuff, right? And so rather than having to figure that out at the application level every single frame, pass that off to another system, and then have that system actually perform all the uploading to the GPU and all that stuff, it actually makes sense to just have a sort of renderer, an application renderer, whatever you want to call it, at the application level that just does it, right? That makes direct calls to the renderer to actually do the thing. So we're going to eliminate a lot of code. We're going to eliminate a lot of overhead. We're going to gain some performance because we're not doing all of this stuff. And of course, that just makes the whole thing easier to use. Now, what I will be doing, so I'm using Illumina as sort of the test driver for this, right? So I'm removing the render graph configuration from Illumina, and we're standing up an Illumina specific renderer. Now that renderer right now aligns with what the testbed and the other project that we have does right now. So the nice part about that is I'll be able to actually pick this up and just kind of apply it there. But at some point, those things are going to diverge, right? And so, this is kind of the way to do it. So we're essentially going to take all of these projects and remove the render graph configuration, remove the need to use these nodes and all this other stuff that goes with it, and replace it with a game-specific renderer or an application-specific renderer, because that just kind of makes sense, right? Render graphs are state of the art, right? But if you think about what we're doing here, we are creating a small, lightweight engine. I'm not looking to create something that has the complexity of Unity or Unreal, right? I'm one guy. I can't do that. So I'm not looking for something that is super highly configurable to the point of having to make super generic code that then has lots of logic that has to run to figure out how that generic stuff should run. The problem that we're trying to solve is highly specific to the end application that we're writing. So it makes sense to do it this way, right? And actually, there are projects out there that do it this way as well. Grand Theft Auto comes to mind, right? Let's see. So yeah, render graphs are state of the art for large game engines like Unreal or Unity or Godot, right? But I'm not looking to compete with that, right? It's too much, right? We don't actually need it. We've gone through the exercise of writing it, right? As an experiment. We do lots of experimentation on this. So if you want it, it's there. It'll always be in the source history, right? But we aren't going to use it for any of our projects going forward. I'm looking to trim things down, trim the fat, and make this whole thing just easier to use from a code perspective. Let's see. How useful do you think your engine series is to someone just learning C and whose first project will be an engine game mix? How would I go from knowing C code to knowing what code and how to code it? And how did you get to this point? Okay, so welcome, by the way. The first thing that I always suggest if you're learning C and you want to get good with C is actually don't start with a game engine. If you've never written this kind of code, don't start there. Start instead with a string library, a string utility library, right? So rather than using the functions that come with the standard library, you want to kind of create your own, string with all the string processing functions. So joining a string, splitting a string by characters or substrings, reversing a string, converting numbers to strings and strings to numbers, and formatting a string, and like all of those functions that you typically find in a higher level language like C# or something like that. Go through that sort of list of functions that those higher level languages provide for strings and implement that in C. And I guarantee you by the time you're done with that, you will be a lot more comfortable with C. At that point, then I would say jump into this kind of stuff. But I wouldn't start here. Maybe your render graph needs redesigning. Again, though, the render graph isn't meeting the goal that I'm trying to meet here. You could generate render graph code, compile it, and dynamically link it. Yeah, but that's right. Like that comes with complexity, right? There's lots of complexity with that. I'm going for simpler here, right? Take a custom DDL and output C code. To me, render graphs seem to trivialize all the neurotic resource tracking. Yeah, I mean, yes and no, right? But again, like, if I were to redesign the render graph again and make it more flexible, that's more generic code that I would have to add to do that. And I'm trying to actually simplify things, right? My view of the render graph is for declarative definition of the rendering process. Inlining everything loses the flexibility to change or support multiple ways to render. Yeah, so generating and hot loading render graph. So here's the thing though, right? So our game code is hot reloadable. So because I'm doing this in the game code, I can make changes to the way that this thing works within reason, as long as I'm not changing memory layout, and still have that hot reloading, right? So I'm not really losing that. But yeah, I mean, in terms of flexibility or multiple ways to render, you're not losing that at all. You're gaining a lot more flexibility, right? Because you can actually come in here and change the renderer to render the way that you want it. Probably what I'm going to do is come up with like a basic renderer that an application can use that'll have all of this stuff in it with comments and stuff, saying if you need to adjust this, you can add this or remove this or whatever. So that there's some example out there besides just this game here that isn't open sourced. So once I get this working here, I am going to move that to like the test bed, for example, so that there is a clear example of how to set one of these things up, as far as that's concerned. What code editor is that? This is NeoVim. I actually have a whole article that I wrote up on my NeoVim setup. So there's that. I think Activision had interesting solution. I should rewatch the render graph talk. Even their prototype seemed promising. To do the thing. Yeah, exactly. Yeah, do the thing, right? That's kind of like when I'm scaffolding stuff out, I do that a lot. So here's the other thing, right? If you're comparing this to what Activision is doing, right? All of Activision, like that's a whole ass team of people. That's several teams of people working on that stuff. You know, I'm not even going to try to compete with that, right? That stuff is awesome if you have a team of people to maintain it, but that also makes the code base huge and bloated and complicated, right? So that's opposite of what I'm trying to achieve here. So I hope that makes sense. Over on the YouTube side, there's another question about my code editor. I am using NeoVim. Let me see if the bot actually picks that up. Should. There it goes. So there is a link over there on the YouTube side to my NeoVim configuration. All right. So that is begin frame. The next thing that we're going to do here is we're going to do clear color, right? And this one is going to require some stuff, but again, not too crazy, right? So we do have an initialize, but again, it's a no-op, so we don't have to worry about that. We do have, let's see, we do have a load resources on this one. So this one actually just grabs the bound source and then uses sort of the internal, assigns that to the internal buffer texture, right? So we are going to need that in our state. So that's going to be the first thing that we're actually going to add. So we can get rid of this guy, and we're going to do K texture, and this is going to be color buffer, right? And that is going to be the first thing that we're going to have to actually provide. So actually come to think of it, when we go ahead and create, when we go ahead and create this, we probably ought to pass that here, right? So we're going to do K texture, color buffer, and K-texture depth buffer. I guess I should do depth stencil buffer, right? And we're going to have that here as well. We're going to need that for the next one, so I'm just going to go ahead and add it. Depth stencil buffer. Okay, so we'll take this and just go down here. Okay. So what we'll do is, this is not going to be a to-do anymore. Actually, I don't even need this comment. It's kind of unnecessary. We're just going to do out renderer color buffer equals color buffer, and then out renderer depth stencil buffer equals depth stencil buffer. Okay, and then we'll have those available to use down here for the clear color. Okay, so that's all that is being done here. This doesn't actually load the resources, so this is a bit of a misnomer, right? In this case, it just assigns the resources, but there are ones that actually do stand up and load resources, but that is something that we're not going to have to actually do going forward. So what we actually want to take a look at is execute, right? So execute essentially just begins another debug label, and then it goes ahead and clears the color buffer, right? So I'm just going to paste this in here for now, and we'll clean it up. So we don't actually need this internal data thing. And we don't actually need, let's see, khandle. We do need the handle to the actual texture. So we need the texture system. And then this is going to be renderer. And this is going to be color buffer, right? And then let's see. Whoops. Let's see. This also, I think, needs the renderer system state, right? So that's another thing that we should probably go ahead and cache, because we don't want to have to constantly keep looking that up. Thank you for the follow, by the way. Let's see. What was that again? What was that? Struct render state. And you know what? I'm actually just going to do this. Let's see, we'll go here, and I'm actually just going to paste this right here. So this is going to be renderer, right? So we need to forward declare this, because I don't want to actually have to include the renderer header at this level, right? So let's go ahead and do that. And then I guess should we call this renderer system? I guess we should call this renderer state. I guess that'll work for now. Okay, so this needs to be renderer renderer state. Okay, and then here we just need to do a quick out renderer states equals engine systems get render system, right? So pointer to the renderer system states. So we'll do that once during creation. That way we don't have to do it after the fact. The only other thing is going to be getting rid of the self name. So that's going to be, let's see, what do we call that? Clear color, right? So we've got something that shows up in RenderDoc for that, our debug label, right? And just as a reminder, this stuff becomes a no-op when we're not building in debug mode. All right. So that's clear color, right? That's all there is to it. We don't have to worry about the destroy either, because that just cleans up the name, which we're not going to deal with anymore. And then the sources and sinks. So again, we don't have to worry about porting over any of this, right? So instead of all of this stuff that's required by the render graph, this is literally all the code that's required for this, right? So it's a huge reduction in logic. Let's see. Wait, are you making an entire game engine, commercial game engine, or an engine plus a game? So it's not a commercial game engine, although it can be used commercially if you want. Although I obviously wouldn't recommend that yet, because it's very much under construction right now. But I am making both a game engine and a game on top of it. So Illumina is the name of the game that we're creating, or it's actually Shadows of Illumina is the full name of the game. And then Kohi is the actual game engine itself. And so right now we are actually kind of refactoring. We're factoring out the render graph out of the game code, and we're replacing it with a game specific renderer, which is going to reduce code quite a lot. So that's kind of what we're doing here. Activision probably had a small graphics team. Larger teams are more often a bottleneck rather than a well-oiled machine. Yes, you're right about that, but baguettes, companies of that size generally just hire the crap out of people anyways. And they usually have large teams, and usually it's a small version or a small number of people within that team that do most of the work. But yeah. Does this engine have a GUI? Kind of, but it doesn't have an editor per se. We're going to build that as well. Yesterday I watched Cathode Ray Dude's video on YouTube about X Server on Windows. Like the early ports, very cool stuff. I love the early 90s GUI aesthetics. Yeah, I do too, actually. Much simpler, right? Does Activision use NeoVim? I doubt it. They probably use Visual Studio. If I had to guess. Okay, so that is the clear color. Let's do the clear depth next, because that is the or the clear depth stencil, right? Clear depth stencil, right? And this is going to be pretty much the same logic as this. For clear color, only for a slightly different call, right? So I'm just going to grab all of this, and we're going to be able to eliminate about half of that code, right? So this one is clear depth stencil, right? And we're going to scope this as well. All right, so we don't have this. We don't have, well, I guess we do have some of this stuff. Okay, so renderer state for that one. Instead of buffer texture, this is going to be renderer depth stencil buffer is what that's going to use. And then for clear depth state, or clear depth set and stencil set, we are actually going to have to store those values, I believe. Well, actually, no, we don't. We can actually hard code them here because this is game specific, right? So we can actually do that. I could store them in the state, right? But that's kind of like something that's not ever really going to change. So I don't think we actually need to do that. So let's do renderer. And then this is going to be renderer state, and then, oops, one character off there, and then depth clear value. So let's see, do we actually have, yeah, see, we have like defaults that we use, and I don't think, oh, we did set them here. Okay, so we set them in configuration before. I'm not going to do that. So the depth clear value is going to be 1.0, and the stencil clear value is going to be just 0, right? And so this doesn't need to be configurable, right? It's configurable here, right? But like, because this is application specific, this is fine. So what we can do here is just change this to clear depth stencil. And that is it. Once again, right? It's pretty straightforward stuff. We don't have to do any of this deserialization of configuration, sources and sinks, none of that stuff, right? The only stuff that matters is this. Okay, so that eliminates that one, right? So these are so far so good. So far, pretty quick. That is about to change though, because we are going to handle the shadow, the shadow pass, right? So this is one item that I would like to kind of think about a little bit. So our resolution here is essentially hard-coded to 2048. I would eventually like to make that configurable. So, you know, that is an example of something that we could set up a function on our renderer to be able to just change that. And whenever we change that, we just regenerate the shadow textures and go from there. So, let's see. Can you show us what you've made so far with your game? So there's not much game code yet. So essentially the way that this has worked, right? This is a brand new engine. We spent a lot of time actually working on the engine. And now we're just kind of starting to work on the game code. But what we've done is we've actually discovered that there are several pain points in using the engine, like the APIs and stuff like that, are a little bit weird in some cases and a little bit hard to use. And so I'm addressing those things now. So we're doing a lot of back and forth between engine code and game code. And so we are setting up a game renderer now. But since I'm in the middle of that, I can't run it. You know, the further on that we get with this, the less we're going to have to touch engine code and the more that we're going to be into game code. But we haven't really gotten to the point where we have gotten past initialization, right? So there's not really much of anything to show. I wonder, I haven't tried to build this yet, so it might actually still run. But there's like not much of anything to show, right? We've got just some test shapes here that move back and forth. You know, we've got some sound, which you guys probably can't hear because I don't actually have that wired in, but you can see the messages here playing. And the ability to, you know, sort of go into a trigger that I can use to warp to a different zone. There's not really a whole lot to show off yet because most of it's just been getting the core systems of the engine up and running. You know, as we continue with this, we'll have more and more game code that gets added. We actually have done a little bit of invisible work as well. We did set up like an item database, is what we call it, an item DB, which is sort of a flat file database system that we're going to use for not only all of our items, but all of our localized strings, and probably a lot of other things like quests and stuff like that. So we have done some game systems like that that are kind of core base things that we need to build before we can even start building our game code. So there's lots of things that we have to do like that before we can actually start visually putting things together. Unfortunately, that's just kind of the way it goes, right? I hope that makes sense. Let me see. What did you do for your asset pipeline? Are you directly loading GLTFs? Nope. So the asset pipeline, we actually recently redid it. And GLTFs are on my to-do list, but I don't have them supported yet. We could support them, I just haven't added it. So right now for static meshes, we support OBJ format, which is not the greatest format, admittedly. But we do have a proprietary format that we import to. We have a proprietary texture format that we import to. We have a new import pipeline set up. GLTF. Yeah, I've looked at that. If you don't fancy writing a parser yourself. So that is one of the places, like one of the goals of this project is to not use really any libraries or as few libraries as possible in the core runtime, right? But in the importer, I'm not above using libraries. So I just need to write an importer for GLTF, frankly. Went with FBX because UFBX is so good. Yeah, FBX is another one that I'm going to have to... what is the mesh format like? It's just... it's simple, right? It's simple like a lot of our other stuff. It doesn't have a whole lot of complexity to it at all. We do need to also write an animation system. So that's going to be a little bit more complex in terms of skinned meshes and things like that. Our static mesh system doesn't support that. We're going to have a separate system that supports that, but we're not there yet. That's another thing on the to-do list. After we get ready, or after we get done with this and the scene work, that's actually next on the list. Okay, so the shadow pass. So the shadow render graph, wait. Yeah, it is shadow. This one. Okay, so this one is quite a bit more complex than these other ones, right? Because we actually deal with resources in this one. We actually have an initialize phase on this one. We have a load resources, which actually does load resources for this one, and then an execute phase as well. So, and then we also have, I believe we actually do have a few things to set some state objects. So I kind of want to think about this a little bit in terms of how we do this in a way where I don't necessarily have to make it as complex as it is here, right? So I'm going to knock out the first, sort of the basic properties first, and then we're going to proceed through the rest of it. But we are going to be able to eliminate a lot of things. So one thing that I don't like, and this render graph node really accentuates this, is we have a whole bunch of state that is stored in here because like we store pointers to geometry render data, right? I don't want to have to do this stuff anymore. I don't want to have to store copies of this stuff, and this is one of the reasons I wanted to get rid of this. I basically want to be able to pass essentially geometries to be rendered and just have those things render when we render the frame, right? So I definitely want to come up with a way to support that in a little bit better of a way than what we're doing here, so that we don't have as much copying data around and stuff like that. But anyways, let's see. I guess probably the initialize is going to be the first thing that we need to do. Let's see. So we do have a number of things that we are going to have to set. Let's see. So we need the shadow map shader. We're going to need we are going to need some shader locations associated with that. So we are going to need that stuff. Also for the terrain, if we do decide to actually support that, we're going to need that as well. I probably ought to just go ahead and copy all of that stuff over. We're going to need those things. And then loading resources, we are going to need acquisition of shader resources, and then somewhere in here, here we go. Here's the actual shadow texture that we render to, right? So there's kind of a lot of stuff going on here that I want to kind of get away from having to do all the time. I think OBJ is an ideal 3D format. It only lacks skeletal animations. Exactly. That's kind of a huge lack. Wrote a custom extension to OBJ that covers that, though. Need to release that part of my small libs, but it's been on hiatus for a long time. Yeah, my guts. I mean, that sounds pretty awesome, right? But ultimately, my goal for this is to like try to support common formats. So I don't, I guess I don't have to do that for this first game, right? But it is something that eventually, I don't know why Automod caught that message. It's something that I need to do, but it's not something that's super high priority for me. Not ideal though. It's one index for some reason. Yeah, I know. Yeah, you have to do a -1 on all of your logic for that, which is kind of annoying. All right. So we have render frame here. We're gonna actually put that on hold for a second, and we need to come up here to create, right? And so this is where we are gonna do shadow pass data, right? And so create here is both going to acquire any shader resources and acquire any textures or load any textures that we need or create them, etc., etc. So I guess it's technically going to combine the load resources here and the initialize here. So let's see, we need shadow static mesh shader. I think that's just a K handle to a shader. I really need to change that or update that in the shader system, but for now I will just use a K handle. That's fine. So let's do, I think I might actually have a substructure on this. So let's go with Illumina depth. No, Illumina shadow pass data. Right. And so that's going to include a K handle to the shadow static mesh shader. And then we also have another one of these for, I need to include K handles. Terrain. And this should probably be height map terrain shader, right? We're going to call it that because we're kind of renaming references to that all over the place. All right, so we need shader locations. So let's see, did we define a struct for this? We did. I don't think I'm going to bother with that. I think what I'm going to do is just kind of include it in this data here. So I think those are U16s if I remember correctly. Yeah. All right, so U16 shadow, I'm going to say shadow SM view projections. That's kind of long though. Actually, I guess I don't have to call it. I could just do that, right? I don't need shadow, I guess. View projections location. U16, we'll do SM model location. U16 SM cascade index location. U16 SM let's see, base color texture. Let me think. Base color texture, that is going to be for the albedo because we need to be able to sample transparency in some cases. Okay. Base color text location, and then U16 SM base color samp location. And then the terrain shader, I think we can actually, let's do HMT shader, right? We'll say height map terrain, and we'll do static meshes. I do want to sort of, I do at some point, I want to see if I can unify these into one shader, but for now they are different because the vertex formats are different. Such is the way of things sometimes. So U16, we're going to do HMT. Let's see, we need view projections. Location. U16, we need HMT. I think it's just model location. And U16, HMT, cascade, index location. Looks like that is all we actually need for that in terms of state, at least for right now. I think that's actually all we need. All right, so we've got all of that. So let's go back over here. And I'm going to do, oops, you know what? I didn't actually put it in here. So let's do Illumina shadow pass data. And I'll just call it shadow pass. So we can do out renderer shadow pass. And then SM view projections location is equal to, in fact, you know what? I think I'm just going to copy. I think I'm going to actually just copy this whole bit, right? And we can just kind of rename what we need to rename. So let me just put this here. And I'll do out renderer. And actually, I'll just do that all the way down. And this is going to be static mesh shader, I think. Shadow pass. Static mesh shader. There we go. Okay. Shader system we don't have, so we need that. We also need shader name, runtime, shadow static mesh. So we need that. I'm not sure. I don't remember where that exists. Where is that defined? Runtime defines. Okay. So I guess we could do include runtime defines. All right. So we have that. Let's just do that. Get rid of this. Okay, so handle is invalid. So this just needs to be the out renderer shadow pass dot static mesh shader. And then this is all going to be shadow pass. And then this is just going to be model location. SM model location. In fact, this is going to be SM underscores for all of those. And then underscore location after all of these. And I believe I abbreviated these thusly. Okay. So if we just move this guy over a little bit, we need, let's see, I should probably just get like a pointer to this, I'm thinking. K-handle shader. Because I don't want to have to put this every single time, right? So K-handle SM shader. Let's just shorthand it, right? Out renderer, shadow pass, static mesh shader, right? We'll just pass that. SM shader. Yeah, okay. Change 3 words. SM shader. There we go. Okay. That's a little bit better. Let's see. MD explains, how you doing? Good to see you. Zany Graphics is asking, how did you learn all of this? Practice and lots of reading. Lots and lots of reading and writing lots of code and throwing away lots of code. And repetition and lots of reading. I've been doing it a long time. Singy, good to see you. How's it going? Great to see you. Seems like a lot of work. It is a lot of work. Is this a 3D or 2D or both game engine? It can be either. Yep, so both. Don't make me scream in my nerd voice. Removing the render graph, why did we fail? So, no, we didn't fail. I'm just looking to simplify things. So, the problem with the render graph is while it's configurable, right? And while you can kind of link things together through that configuration, there's lots of code that's required to actually support that. And because it has this sort of generic interface that it uses, there's lots of overhead associated with that. And so I've decided that since the actual application project itself knows what kind of deal or what kind of data it's dealing with, what needs to be rendered, how and what order, things like that, it makes sense to have a bespoke sort of renderer for the individual application, because that is going to vary. And rather than having this thing that I have to configure and potentially write new nodes for if I need some other way of rendering, it makes sense to just kind of do it in one place in the application and have it be application specific, because the application actually knows what needs to be rendered. So instead of trying to make this generic thing that's in the engine and just sort of punting that to the game anyways, why not just remove that bit, put the actual, procedure for the renderer in the actual game, since it knows how it needs to work, and go from there. And so I'm doing that first with this game project, and then I'll probably come up, I'll make like a base one that can kind of get included with the test bed or whatever, or maybe even with the engine that you can use if you don't want any sort of specialized rendering, and to serve it as an example of how you'd set one of these things up. But yeah, we're going to have a bespoke sort of renderer for at the game level now, because it's just a lot simpler. So yeah, I hope that made it implementation specific. Yes, exactly. Yep. Which makes sense, because again, it's the implementation knows what data it's dealing with. So rather than going through all of these generic interfaces, which has overhead with all of that stuff, it should just be defined by the implementation. Not to be that guy, but why C++? Or why not C++ rather? Because I would go mad if I had to do an engine without OOP. Because I'm doing an engine without OOP. We're not really doing OOP here. There's a couple of things that kind of approach it, but yeah, we're actually trying to avoid that. And I'm actually trying to remove some places where we got close to OOP, because in most things for a game engine, especially one that doesn't need to be complicated, you don't really need it. And so I didn't need that. I don't use 90% of the features that C++ has anyways. Essentially my C++ looked like C anyways, minus a couple of things. And those couple of things I could live without. So I just decided to write in C instead. And I prefer C. It's a simpler language. It compiles faster. I just prefer it. My engine is functional also, and I was born mad. Yeah, Adam, I get that. Totally get that. Wasted extra years for my functional engine, and it was worth it. Yeah, I mean that's the thing, right? Is like I'm like, if I wanted to make another OOP game engine that uses an entity component system and has an Unreal like editor, like why would I go through all of that to write something that already kind of exists out there? Like I don't need to rewrite Unreal. I don't need to rewrite Unity. I don't need to rewrite Godot. Those things already exist. That'd be pointless to rewrite those things. And so I'm not. I'm going a different direction. Okay, so that's the static mesh shadow map shader, and now here is the we're going to say height map terrain. Got it. My C++ is also basically C, but with OOP and modules. Don't care about the other stuff. Yeah, that's the thing, right? And the longer I wrote C++, that way I'm like, why am I doing this? Why not just use C? The only things I really miss from C++, there's two things I miss. Constant expressions, which technically C23 is getting, but I'm not doing that for portability reasons. So there's that, and then operator overloads for the math library. Those are really the only two things I miss. All the rest of it, you can have it. Shadow pass, HMT shader, and let's see. This is going to also be out renderer, shadow pass, HMT shader, right? And that's actually going to be out renderer, shadow pass, HMT shader. I'm gonna have to do that a couple more times here. There we go. And locations. So shadow pass. In fact, I'm actually just gonna do that. And then I'll do HMT underscore here as well, and then location. All right. Okay, so now we have just misspelled height map for one thing. Now we have the shaders being loaded and all of the uniform locations retrieved from said shaders, which is the first step of that our render graph node was doing, right? So that is one thing down. We are good there. So the next thing that we'll need to do is we'll need to actually perform the same things that are done in load resources. So load resources, we have some notes here. We should probably read through these real quick. Let's see, for static meshes, the alpha of transparent materials needs to be taken into account when casting shadows. Yes. So we do actually need to, the way that this needs to work is we need a default texture to use whenever we are not dealing with a transparent material. Otherwise, we are going to use the base color texture from the material whenever we are dealing with something that does have transparency, right? So I'm actually going to take these notes over with me. So we do that. We get shader group acquisition from the shaders themselves. We create a viewport to render through, and then we go ahead and we grab or we create the shadow map texture, right? And then the bind it to source, we don't have to do that anymore. So I'm actually going to take this whole section. And again, we're just going to kind of refactor and keep what we need and throw away the rest. So here, you know what? I think I'm going to scope this as well, just to make it a little bit more obvious as to where one begins and the other ends. All right, so what we need here is, let's see, default base color texture. I don't think we actually have that in here anywhere. We do not. Okay, so I am going to need that in here. So K texture, default base color. So that's, again, just the texture to be used for that whenever we aren't dealing with a transparent material. So that's going to be used whenever we, for example, whenever we use or render terrains. Terrains aren't see-through, so we'll just use that. We probably could... We should probably modify this to just not even sample a texture at all in that case, rather than doing it this way, but we can change that later. I'm not looking to refactor the way this works right now, just move it, right? Base, default base color, there we go. So that is acquired there, and then we just need to out renderer, default base color, and then it needs to be shadow pass dot. There we go. Okay. Also, I just realized some of our error messages are referencing the render graph, right? So we should probably not do that. Failed to load default base color texture when initializing. Renderer shadow pass. So we'll do that here as well. Okay, so this is shader resource acquisition for the group. So this needs to be out renderer, and then shadow pass, and then this is for the... Which shader was this for again? The static mesh shader, okay. Static mesh shader, there we go. Okay, and then we have this default group.group ID. What was that structure doing over here? I forget. Default, let's see, shader group data. I feel like we can do better than that, right? I feel like we don't probably need to cache all of this stuff. I feel like we can handle this better than that. So let's go to we have a raid. Apex Pixelated raiding with a party of 14. Thank you so much for the raid. What did you get up to on stream? Sorry, I was kind of in focus mode there. Tell me about your stream. Tell me what you got up to. Thank you so much for the raid. Welcome, raiders. And Art Berkelaus also raided with a party of 16. Thank you so much for the raid there, too. What did you get up to on stream? I don't think I can do another shout-out yet. I'll have to wait a minute for that one. But thank you guys so much for the raid. Building in a save system for a game. Nice. Fixing some issues with importing my animation assets. Awesome. Yeah, no problem at all for the shout out. Thank you so much for the raid. I really appreciate it. I don't believe I am following you, but I am now. Art, how are you? Good to see you. I've been lurking in your streams. I haven't been able to fully engage, but what were you up to on your stream? Thank you guys for the follow. So I guess I should go ahead and do my intro here, just to kind of talk about what we're doing. So we are working on something called the Kohi game engine. So this is a game engine written from scratch in C using Vulkan as its initial rendering backend. There are plans to support Metal as well as DirectX as well in the future, but for now it's just Vulkan. It is cross-platform, so it's available on Windows, Linux, and Mac OS. And it's designed to be sort of an educational series on a way to build a game engine. It's not necessarily the only way to build a game engine. It's not even necessarily always the right way. Sometimes we deliberately do things the wrong way to determine why that's the wrong way and do a deep dive on that thing. You know, we do lots of exploration and trial and error in here, and we try out different things to see what works and what doesn't. And we kind of go into the reasons why. And we also, talk a lot about thought processes and design, things like that. So the series has been going on for quite a while. It started off as a tutorial series on YouTube, but we quickly outgrew that format. And so now we stream live here on Twitch. The engine itself is free and open source. In fact, let me just drop a link here to this website here. That's kind of the central hub there. So the engine itself is free and open source. It is Apache 2.0 licensed, which means that you can use it for commercial, independent, personal, does not matter. All that I ask is that if you use it, just say you used it. That's literally it. It's an educational series. It's an educational resource. So nothing having to do with the engine will ever be paywalled or behind any sort of thing like that. There will never be any licensing fees or royalty costs or any of that stuff. It'll always be 100% open source and free. The game code, not so much, because, obviously I want to release that and eventually sell it. But, the engine itself is always going to be open source and free. A couple more things just to kind of talk about. There are some other links here on the website to the YouTube channel, the Twitch channel. We do have a Discord server with about 1,000 people on it. And of course, we have the GitHub link here and a Patreon link here. I don't have any sort of sponsors or anything. It's just you guys. So, that's basically what I've got there. And like I said, the source code is available. This is a pretty young engine, all things considered. We've got a basic PBR pipeline. We have, and actually these screenshots are a little bit dated, but, we have UTF-8 text rendering. We've got, a lot of different things. We've got the ability to, select objects in 3D and move them around, translate, rotation, scale, all those kind of things. So we've got, a few things just kind of listed here or shown here, cascading shadow maps. We have the start of a UI system as well. But yeah, this is pretty much what we're working on right now, is the engine. Now, we are also, part of the deal with this engine is we are actually going to make a game with it and release that game on Steam is the goal. So the game itself is called Shadows of Illumina, which is the references to Illumina that you see here. That's the actual game code. So we're in game code right now. We're in the process of removing our render graph because that was one of those experimental features that we tried. And it was successful. It did work. But, it had, a lot of overhead and complexity that I wasn't really fond of. And so this is one of those things that we did an exploration on, and now we're going to, sort of back that out and remove it in favor of a game or implementation-specific renderer. And the reason for that is, as I mentioned before, the overhead and code complexity, but also ultimately the application itself that consumes the engine is aware of how it needs to work. And so it makes sense to have this logic there. So we are in the process of kind of reworking that for our Illumina project. And then out of this, more than likely will come a sort of base kind of renderer that we can use if you don't need any sort of specialized rendering. Once I finish this guy, that will probably be born from this, and then the two can diverge. But yeah, the idea here is that we do a lot of stuff from scratch. We try to avoid using third-party libraries wherever possible. I do allow them in our imports. So our imports, our import tooling, or our import tool chain rather, does make use of some libraries, things like STB image, STB OGG, mini MP3, things like that to actually import assets to our own proprietary format. But the end runtime application is not shipped with those things. And so that is kind of the idea there, that we kind of do a deep dive into creating all these systems from scratch. And we did create this from the ground up, from nothing at all. So I hope that all makes sense. Let's see. Arts was working on merging 2 renderers for his game. One for short distance with full texturing, and one for long distance, which is height map based. Ooh, that's pretty cool. I might have to check out the VOD on that, Art. That sounds awesome. In fact, I might actually be able to do the shout out now. Twitch makes you kind of wait a minute between shout outs. I have to drop, but I'll be back another day to check it out. I appreciate it. Yeah, got to do what you got to do. Yeah, I understand the raid and run for sure. Soulfoam, how's it going? Good to see you. Although you probably didn't hear me because of ads. Yeah, no problem, Art, for sure. And if you guys aren't following Art, he is also working on a game from scratch without an engine. And so I would highly recommend you guys go check out his stuff, because he's actually building his own art tools and everything. So definitely go check out his stream. Give him a follow. Your project's inspiring. I appreciate that. Yeah, so is yours, for that matter. But yeah, thank you for that. In my game, I render stuff that's close to the camera typically, and the far distance stuff with STF. That's fair enough, Baguettes. Or ray marching. Yep. I gotcha. Let me catch up over on the YouTube side. I think there's a couple comments here. Wondering why you chose NeoVim over VS. I prefer it. I'm a lot faster with it. VS Code has gotten kind of heavy and slow in recent years. I do still use it, as a debugger. I did, this is a family-friendly stream, though, so I usually, censor it. I did just accidentally say it, but, usually when I say it, I say VS, because, it's got to keep it family-friendly, I do still use this for debugging purposes, but I'm actually thinking about switching to another debugger here soon. The reason I had used this for debugging is because I can use it, the same setup on Windows, Linux, and Mac. But I'm looking to get away from that. But yeah, for me, it's preference. I'm much faster at navigating with this. The key bindings keep me from having to touch the mouse all the time, although I do it a lot on stream, just to kind of highlight sections of code that I'm talking about. But normally when I'm working on it off camera, I almost never touch the mouse, which is awesome for my hands. Because I actually have, I'm battling carpal tunnel at the moment. So, the keyboard only definitely helps with that. I actually changed my keyboard even recently to get a split keyboard so that, it's a little bit easier on my hands, but I digress. Soul foam. I'm not going to read that out loud, but that's funny. It is not fantastic, though. I disagree with you there. Okay. Is there any resource to learn game dev just in the C language? I mean, this channel, right? Also, Handmade Hero does it. He technically uses a C++ compiler, but basically what he's writing is C. Okay. Oh, I see what you meant. I see what you mean, Soulfoam. Okay. That I will say, yeah. If you like dog crap software, then VS is the way to go. Is what Soulfoam is saying. Cakes is doing what Casey is doing. Is he? His code looked pretty oopy to me for that. Maybe I'm wrong, but all right. Okay, so shader group acquire. We do need a default group ID for that. So I think I'm going to go ahead and just head over here, and we're going to put this here. U16 default group ID. I think it was supposed to be U16. Let me double check that. No, it needs to be U32. My bad. Okay. So we want out shader, or out renderer rather, and then I think default group ID. Did I not call it that? Oh, it needs to be shadow pass default group ID. That's what it was. Okay. Okay, we already have that render shadow pass. So the next thing is we need to define a viewport. So this is the viewport that when you're rendering the shadow pass, this is the viewport that is actually used for that, which differs from your typical viewport that's used by your camera, right? So this is based on the resolution of the actual shadow map, right? And so we're actually using that here, but we don't actually have the resolution here. And if you recall, and previously I was saying I wanted to make that sort of configurable. So what I'm going to do is actually go into the shadow pass, and I'm going to put in here, let's do I guess I'll do a U32. Yeah, I guess I could call it resolution. And so that's going to be the resolution of the shadow map, right? So I guess what we'll do is I guess we'll set a default shadow map resolution. And we're going to do out renderer shadow pass resolution equals 2048, right? And then we'll also do a to-do configurable, right? Technically speaking, this is something that would probably also be in the app config, like maybe maybe like a top level option or something that we can add to the app config. But for now, we're just going to have it here, and we can always change that later, right? Because the user is also going to be able to select a shadow map resolution. I probably won't do it an explicit size like this. I'll probably do like low, medium, high, or off or something like that. But, and then just kind of adjust it behind the scenes. But for right now, we're just going to default to 2048. And then here we can do out renderer shadow pass resolution for both of those. And then viewport create. I don't think we actually have, we need renderer viewport included. And then, let's see. This needs internal data camera viewport. So that's where we're going to store that. So we need to add that to state as well. Let me think about this. I guess this should probably also be here in the shadow pass data. So viewports VP. Should probably rename that to like K viewport or something. That's one of the things I need to actually go through and change a lot in the code base. But out renderer, shadow pass, VP, and then we can get rid of that. Okay, so that is the viewport creation. Shadow map pass. Okay, we've got that. Here is where we actually create the shadow map texture, right? And so we have shadow render graph node. We're going to do shadow pass shadow map texture, I guess we'll call it, or I guess shadow map's fine. So it's a depth texture. It does not have a stencil buffer in it. the resolution. So this needs to be out renderer shadow pass resolution. Same is true for that. And then material max shadow cascades. I don't know that I actually like having that stored there. I'll roll with it for now, but I think I'm going to put a to-do. Configurable. I think that's because our shader is technically limited to 4 of them, but doesn't necessarily have to be that way. And then depth texture. Do we have out renderer shadow pass? I don't think we have a depth texture on that though, so we're going to have to add. Oops. We're going to have to add. I don't know if I want to call it depth texture either. I think I'm going to do K texture, shadow text. Right? So that's the actual shadow texture that we're going to be rendering to. I suppose I could call it like shadow target or something, but out renderer, shadow pass, shadow text. And then this is going to be shadow pass. Fail to request layered shadow map texture for shadow pass. Yeah, good enough. Okay. And that is going to be it for the resource acquisition. Oh, dang it, Sulfoam. I saw your message. Who's Cakes? Yeah. You know who Cakes is, Sulfoam. Thank you guys for the follows. Appreciate that. Sometimes the auto mod like times out. It's kind of annoying. Okay. So we have all of our resources gathered. So the beauty of this is we're not going to have to do any of this internal data stuff. We're not going to have to do any of the sources or the sinks. None of that stuff is going to have to exist in our new code, so we can get rid of all that. Load resources we've done. So the next big one is going to be this execution of it, right? So that's going to be kind of the large piece of this. So the general idea here is that we clear the image, right? So that's going to be all layers of the shadow texture that we created here. And then we go through the cascades. We set all of our uniforms. We begin rendering, set the viewport, set our debug label. We use the shader. Which I guess we don't actually have to do this. We could just use the shader once. No, we actually have to switch a few times, which I kind of want to get away from too. But again, I'm not refactoring the way that this runs right now. I'm just kind of moving it, right? So we apply the per frame updates, right? So that's like the top level once per frame updates, right? So we bind the frame updates. We set our uniforms. So at that level, the only thing that we have to actually set is the view and projection. And we do that once per cascade, right? Because those vary. And then we go ahead and apply that and the debug level. And then we reset the handle group for all entries, not the group IDs though. So this is kind of the section I want to see if I can't maybe clean up a little bit. Because I don't think we need to cache like all of this data. I'm just wondering why I was thinking we had to do this. I think we can actually just like apply it directly, right? So here we actually figure out how many per draw resource acquisitions we need, if we need more or less. If we need more than we already have, then we acquire more for each of those that we require above what we already have. This is the prepare, so we make sure that we have enough resources for the entire frame. This is where we actually look through the material itself. So in this case, I think, are these actually already sorted? I don't remember. I believe they are. So the way that this should work is for each one of these static mesh geometries, we check its material. If it's transparent, we go one path. If it's not transparent, we go another path, right? So basically, if it's transparent, we essentially have to sample the base color texture to get its transparency. So that's for like textures that have like the tree leaves, for example, right? We want the light to come through those leaves, so we need to sample the transparency of that. So that's what we're doing here. But we only need to do that if the material is actually transparent or has any transparency. If not, then we just kind of use that default texture that we grabbed earlier. And then we do the group uniform updates. We bind the appropriate texture. And then, let's see, we apply the per group settings, and then we do the per draw uniforms as well. And then we kind of do the same thing again for terrains, although terrains are far less complicated because they don't actually have any transparency to worry about. So we don't ever have to actually worry about any of that stuff. In fact, per draw resources for the frame, I am actually thinking we should probably refactor the way that the terrain works, right, to get rid of the per draw resource requirement. Because I don't believe we actually need it. Thank you for the sub over on the YouTube side, by the way. Let's see. Cakes who? Yeah. Never heard of the guy. He's Cakes' stream is a lot larger than mine, that's for sure. I don't know, though. I mean, people give Cakes a lot of crap, but I like him well enough. He's a good guy. He says some weird stuff sometimes, but, you know, it's whatever. Okay, so, I am actually thinking, I wonder if we can split some of this off into the prepare frame. Not really, I guess. I think we're just going to put it all in execute for now. All right, so execute. Now this is going to be the shadow pass, right? And I use the term pass loosely because it's not a Vulkan render pass or anything like that, right? So let's see. Let's take, I guess let's take this whole block, right? Prepare the image to be sampled from. I am going to need that as well. And then end the render debug label. Okay, so I'm going to need all that stuff. We're probably going to have to trim a lot of stuff out, and that's fine. All right. So obviously the first thing we need to do is begin a debug level. Or debug label rather. I'm going to say shadow pass. And then internal data, we don't have that. Depth texture handle. So that is going to come from, oh, I wonder if I should actually cache that as an optimization in the future. I suppose like that could become out of date if we regenerate the texture, but if we regenerate the texture because we changed shadow map size or something, we'd know about it anyways and could update it. So I think it should be fine to cache that in the future, but I'm not going to do it right now. Renderer, and then we want shadow pass and then shadow texture, right? I'm going to rename this to shadow text handle. Good enough. All right. So we get the underlying renderer handle to it, and then we go ahead and clear depth stencil against that, right? Then we go through the cascades. So the label text we generate here. So let's see, shadow cascade index P, which is here. So this is string format, so we probably don't have that in here, so we'll just add that. So we begin a debug label for each one of the shadow cascades, right? And that's kind of what gives us the ability to kind of examine that in RenderDoc, right? The individual passes if we need to for some reason. So this is going to be renderer, and then shadow pass resolution, and then this is going to be renderer shadow pass resolution. Render area. Didn't we already do this once? I feel like we did. I feel like generating that every time is kind of a waste, but I'm going to put it to do. Put a pin in it. All right, so begin rendering. So this needs to be renderer, renderer state. So that's that. And then active viewport set. So instead of camera viewport, which is not accurate at all. It's going to be renderer and then shadow pass VP. Okay, so another debug label. So this is the per frame stuff, right? So we're going to say render graph static mesh per frame. Right, so here's static mesh stuff. We're going to use the renderer shadow pass static mesh shader, right? And then change that over to that. We're probably going to have to do that a couple times, actually. Let's just move this out of the way. So let me do render shadow pass static mesh shader. I feel like we're going to have to do that a couple times throughout here. So I guess let's just try to find those real quick. All right, here's another one. I don't necessarily want to just do a blind find and replace because that might replace things I'm not accounting for. So just kind of go through and just hand pick these, right? So that's going to be all of these guys. Right. And then, all right, so this all is for the terrain shadow map shader. So we're going to come back to this. We're not going to deal with that right now. So this is locations, right? So we're going to have to change this as well. Thank you for the follow. I like Cakes too. He's goofy enough to keep stuff interesting. Exactly. Yep. Have you looked into spherical harmonics for global illumination? Nope, I have not. Frankly, I'm not going to need global illumination for this game, so I'm probably not going to get into that, right? I'm trying to basically just do what I need for this game, and then I can always add stuff and make it more fancy later. Because I could get stuck in, the rabbit hole that is rendering stuff like that and be there for quite a long time. But I don't want to do that. I'm looking to actually ship a game. So I don't want to spend too much time on that kind of thing. At least not right now, unless we actually are going to use it. Okay, so we have this concept of cascade data, which we don't technically, we don't have yet, right? So what this is these cascade data structures have a number of pieces of data that we need per cascade that gets set in uniform locations like this. So one of those is the view projection matrix, which is calculated technically before this is done. And so that is a piece of data that we have to find out. We have to figure out, do we want to pass it every time? Do we want to cache it? I'm thinking the latter, but for right now, I just kind of want to fix some of the other issues in here and just kind of get this all converted over first. So we're going to do shadow pass, static mesh shader. Okay, so here we have static mesh groups, and this was one of the things that I was thinking that I wanted to kind of look into eliminating if I can. So I think what I want to do, so let's take a look at the original source over here. Let's see, where is this? This is here. Okay, so static mesh groups. Let's look at that. Let's look at the structure. So this structure here is for an individual group. Now, what is a group in terms of the shadow shader group data and all that stuff? What that basically is it is there is one group per material. So whenever we're dealing with materials in this, we have one group per material. But it's not quite that cut and dry in terms of how the shadow pass needs to work. Because it's not just one group per material, it's actually one group per transparent material. And then there's a separate group for sort of the default, which doesn't have any transparency. And we just use a just a default white texture for that to sample from. So this group data handles the base, or holds a handle to the base material and the group ID. So we'd need the group ID. Let's see, how do we actually index this thing? So we invalidate them here. And then we acquire. Oh, this is per draw. I'm trying to remember how I did this because it's been like 2 years since I wrote this. So, and this is one of the reasons I'm saying like we need to simplify this, right? So here we loop through static meshes. Get pointers to all the things that we need, right? And then we take a look at the material. Material instance, material. So we ask the material system for this material, does it have transparency? Yeah, I feel like this needs to be split out. I feel like this needs to be split out to possibly our other step up here, our prepare frame. Like this is probably not something we should be doing in the middle of trying to render a frame, right? That should probably be separated out to a separate step because we could potentially jobify this code, and multi-thread it at some point if we wanted to. I don't think it takes all that long to run, but I feel like this stuff should not be happening within the renderer. This should probably be something that we determine ahead of time and pass to the renderer. So maybe even here isn't really appropriate. So we have selected group, group ID. Selected group is default group or static mesh groups group index. So the group index, oh, we do a lookup on that every single time. Oh, that's terrible. Okay, so what we do is yeah, I think I want to kind of, I think I don't really want to do it this way. I want to rethink how we're doing this. Essentially, we need one default group and then one group per transparent material. We could figure that stuff out. Oh, let me think about this for a second. So, yeah, we should probably figure this out before, because this is actually in the context of every cascade we're doing this. No wonder this takes so long. I haven't actually profiled this, but we should actually probably rethink the way that we're doing this. So if we think about what are the actual requirements, what is the actual problem here? What we need at this level is we are essentially, for each of these passes, we need to render a list of static meshes. Now, where that list is stored, how it comes to us doesn't really matter at the moment. We'll figure that out. Within that list of static meshes, each one of those static meshes has a material. Those static meshes themselves can also have submeshes, which can have different materials. So that should be split out. We shouldn't be dealing with static meshes per se. We should be dealing with geometry render data, which basically contains like vertex buffer, index buffer, offsets, and then probably a material instance ID. That material instance ID can be used by the material system to perform lookups of the material. So we would need a list of those geometries, material, and a model matrix for each one of those. So we could group those three things together. And then we would probably want to pre-process those, sort them by material, so that all like materials are together. That way we don't have tons of context switching. We could keep what's track of what's the current material, and then anytime we switch materials, we can essentially figure out what we need to do from there. So anytime we switch materials, we need to verify whether or not that material has transparency. And at that point, we would need to either create a new group for it, or use an existing group if it already exists, or use the default if there is no transparency. So we would need to store that group ID alongside the information for the geometry, the material ID, or the material instance, and the model matrix. And then aside from that, what else would we need to store there? We would need to store a draw ID as well, because we need per draw resources, and a per draw resource is for the model matrix, essentially, and eventually other data as well. But for right now, just the model matrix. Okay. So internally, we need a separate structure. That's going to hold that stuff. Let's do, I guess we could put it that's going to be a structure that is going to be specific to the shadow pass. So let's type def a structure here. We're going to call this shadow pass stat SM data, I guess. Static mesh data for shadow pass. All right, and in this, we're going to need, let's see, do we want a pointer to geometry, or do we want, I don't think we need that actually. I think all we need is like the vertex and index buffer offsets and element counts. Yeah, so we could do, I think those are U64s. So vertex, geometry, vertex, offset, and then U64, geometry, vertex, count. And then U64, these might be U32s. I can't remember. I'll have to look that up. Geo index, offset, and then U64, geo index, count. Okay. So in addition to that, we need a material instance. Material. We need a mat4 model. We need a U32 group ID and a U32 draw ID. So this is essentially the data that we actually need to gather and ultimately pass for something to be rendered at this level. So there's going to be two sets of this data. So there's going to be an external version of this data, which is going to contain all of these things. And then the internal, which also contains this. I feel like we should probably just do this. Thank you for the follow. Appreciate that. Illumina, shadow, pass, SM, data, internal. God, that's really long. Okay. Might have to think about the naming there. But I'll leave it this way. So what we could do here is this, and then take these two and move it here, right? So this is what would actually be provided by the game code. And actually, this doesn't even need to be specific to the shadow pass, now that I think about it. This could be for all static meshes, right? So let's do this. I don't even want to say static mesh render data because it's not even 100% accurate, right? It's just geometry render data. Right? Doesn't even have to be shadow path specific. Geometry render data. Right? Because it doesn't matter whether we're dealing with terrains, static meshes, animated meshes. Although animated meshes may require some other data to be passed alongside this. But we could essentially do the same thing and wrap a structure around it. So let's do geodata. Right, so this is the internal representation of this. So we could take a copy of this data, store it here internally alongside a group ID and a draw ID. And then when we go to actually render it, we would be able to use these to do the rendering. I think that makes sense. So in here, what we really need to set up is one more thing. We need Illumina, Shadow, Pass, SM, Data, Internal. And we need an array of this. And that is going to be... And actually, I just realized something else that we're going to be able to do that's pretty cool. So this is going to be... How do I want to put this? Static mesh data, I guess. I don't know. So cached static mesh data for the shadow pass. Okay, so we could pass a list of these, which contains all the data that we need to figure out everything that we need to do internally. Store these in here. And the cool thing about this is that we can actually use our frame allocator for this. Instead of having to use D-arrays like we were... I think we have... Oh, wait. We might not want to do that. No, we probably need to actually persist that outside the context of a frame, because I don't want to have to rebuild that entire array every single time. In fact, I can't rebuild that array every single time because of the group ID situation. So, in case you're wondering what I'm thinking, when we are drawing a bunch of static meshes or a bunch of any kind of geometry, right? This needs to have enough group IDs and draw IDs to handle everything that's being rendered at once. Now, the number of rendered objects can change from frame to frame and will change from frame to frame. So we need to keep essentially a list of group IDs and draw IDs that are available between frames, so that we know how many we currently have and how many we need. And if the number that we need is currently then greater than the number that we have, then we need to go ahead and request more from the shader. I could just request a bunch of it up front, right? But I feel like that's wasteful. But also having to check that every frame kind of sucks too. So I guess what I could do... Yeah. Checking that every frame is rubbish. I don't want to do that anymore. It is more dynamic, yes. But I think it's like way overkill, right? So let's do this. Let's do U32 max group count and U32 max draw count. And essentially what we'll do is whenever we're processing a list of these things, we will just essentially, if we hit one of these limits, we'll just skip drawing the thing and we'll warn to the console. And then we'll just manually update that if we need it. And if we hit a scene that really has a lot of objects, then we could just up it. Because we don't necessarily need to be dynamically requesting these and releasing them all the time. So I think it's reasonable to do that. And then I don't have to check every single frame. Well, how many do we have? Do we have enough? If we don't have enough, let's get some more. Then I can just say, I can just check here, right? So I guess in render frame, I guess we should probably kind of map out the logic the way that we want it to work, right? So we are going to rethink how we're going to do all of this stuff. Let's see, this bit here, from here down. So let's kind of map this out as far as how we want to make this work. So have a set max groups draws, and if that is exceeded, warn but do not draw. Prompt to increase count. So we need to iterate all meshes. Iterate all meshes, or no, iterate all geometry data. Get list of, actually, I guess we could just get count of materials with, no, we don't even need to do this step, actually. We don't need to get a count of materials with transparency, right? Because if we blow past the count, we blow past the count. So iterate all geometry data. Check if material associated has a mapped group. If not, well, if so, use it. Otherwise, map it to a free one. And then yeah, that's it, basically, actually. Now I'm actually thinking, do we even need to pass this? Do we actually even need to manage the draw IDs at all? I think we could just iterate that. Or increment it. Increment draw ID for each draw. Stop at max and warn. No need to cache. Yeah, I don't think we have to cache the draw ID at all, actually. I think we could just use that as is. So actually, now that I'm thinking about it, that simplifies things a lot more even. Because we don't have to check the number of it. We don't have to reset any of this crap either. We don't have to do this at all. All we'll have to do is iterate the geometries. Technically speaking, I wouldn't have to cache any of this if I could figure out a way to, in this step, associate a group to a index within the geometries array. Here's also the rub. For the shadow pass, there technically can be a different number of geometries per cascade. Because, and technically there probably should be, right? Because each cascade gets closer and closer and closer. So, you know, your first cascade all the way out is going to have lots of things within its viewport, but all the way in, it's not going to have as much. So we technically need more than one list. Iterate all geometry data for the cascade. Check if material associated has a mapped group. Okay. So technically speaking, we don't even have one list. Like, that was another mistake we were making here. Is we only had one list of geometries, and we were just drawing that every single time, even if we didn't need to, which is actually a huge mistake. So this for the cascade part is actually an interesting bit as well. I feel like we probably ought to provide this to the renderer somehow. Like maybe we build up some sort of structure that this guy takes. So like maybe we have another structure here. We'll do Illumina, render data. And within that, we'll have another structure. Oops, if I can spell typedef correctly. Another structure, Illumina, shadow pass, render data. Right, and then in this, we have, I guess we don't really need index, right? But we do need a list of these guys. Right, so we can do something like this, right? So we could do mesh data, right? We could probably even just do U32 mesh data count, right? So we have an array of, so we have an array of, oh, this should probably be, should probably be that. Right, because this is going to be per cascade. So for each cascade, we have a certain number of meshes. And render data for that mesh, right? And then here, the Illumina render data, this is going to be all of that render data per frame, right? So we're going to have Illumina, shadow, pass, cascade, render data. Shadow, cascade, data. Shadow cascades, I guess we could say, right? And I guess we could also do, we could also do U32 cascade count, right? And then this would also contain some of the other data that we need that we haven't really talked about yet, which would be map4 view projection, because we need that. The index would come from the index of this array. Let's see. What were some of the other things we needed? I can't remember. What else did we have here? These are just texture and sampler, cascade index, model. That's per draw. I think that's actually it. Okay. So we could have stuff like this, and then we could have, to do height map, terrain data, right? So this would be static mesh geo data, right? And so whenever we pass through, or whenever we go to render, we essentially build up one of these structures. And because of the way that we do this, we can actually use our frame data allocator to set up these arrays and stuff like that. So it only persists the life of that frame, right? And the benefit there is that it's lightning fast, because that's just a linear allocator. So all it does is move a pointer forward. And so when we use that to create this, it makes standing this up really, really fast. And that's exactly what it's for. So when we render the frame, we have, let's see, frame data, and then we have Illumina render data. Render data, right? And then whatever we need that's game specific, we can also pass in this render data. So we can pass things like skybox data or whatever from the scene. So we basically build up this structure here with the entire context of a frame in mind. I don't know that we're going to need the prepare frame, but we'll see. I wanted to put that in there anyways. Legitimate question: how do you manage to keep motivated to work on something for as long as you have been working on it? Good question. So those of you who have been around for quite a while have noticed over the years that I have once or twice hit burnout stage. That does happen, right? Burnout is a real thing that you have to, you can't just pretend like it doesn't exist, right? And so in my case, there's a couple things that keep me motivated, and your mileage may vary on all of this, but for me, when I get burnout, I need to walk away from the project for like a week and not touch it, or maybe even longer. I had that a few weeks ago, and I was dealing with a lot of things in real life as well, and so I was just like, you know what? No streams on this particular week, and I just took the week off, and I didn't even look at the code base whatsoever. And so you do have to kind of step away from that for a little bit sometimes, but the key there is to not step away for too long. Because if you step away for too long, that's also a bad thing, because then it's hard to get restarted, right? So that's one thing. The other thing is by doing this publicly like this, it sort of, in a way, kind of forces me to keep going, because it's like a responsibility to keep going, right? I have a lot of people that are following me on this project, a lot of people that are following the progress of this project and are looking to see it through to the end. And ultimately, my final motivation for this is to release a game on this, no matter how long that takes me, right? And so having that there, that sense of responsibility, or that sense of responsibility is not the word I'm looking for, but essentially, that what is the word I'm looking for? Accountability is the word I'm looking for. By doing this publicly and having you guys follow me along, that holds me accountable to keep me moving on it. And that's a big deal, because I don't want to obviously disappoint, the folks that are following me. So that's a big motivating factor as well. And then also, sometimes if I'm really, really struggling with something, in terms of motivation, like I'm in the middle of a large refactor and I just can't see the light at the end of the tunnel, sometimes that'll cause you to lose a little motivation. What I'll do is I'll sometimes kind of put that aside and then knock out something really simple and small, because having that little bit of progress on something, especially if it's visible progress, can sometimes be a huge refresh and motivation to actually keep moving forward. So sometimes if you've got a really big task that you're working on, sometimes it's better to split that off into a different branch. And then, that way you can actually, if you're like, I really could use some more motivation here, you could just put that aside, switch to a different branch, knock out something that's a low-hanging fruit that gives you visual progress. And that is a huge motivator as well. And there's also the fact that I've gotten past, I've been working on this for a few years now, and I've gotten past that point where, for me, like, it's the shiny object syndrome kind of dies off after a couple of months working on a project, right? So now this is so far along that, I kind of am used to working in the code base, and I'm not thinking about switching to something else because I've been at this for so long. I hope that makes sense. I hope that's helpful in some way, shape, or form. With that said, let me just make sure that this makes a lot of sense. Okay, good. Awesome. Words are sometimes difficult for me, and I know that's weird, coming from somebody who does this online, but that's actually one of the primary motivations for me doing this, is actually to get me better at communicating my ideas, and it's actually worked. Okay, so I think this is probably where I'm going to put a pin in it for tonight, because we have reached the end of the stream, or at least my time for that. So let me just put a left off marker here. Oops. And I will save the session, and let's find somebody to raid. Let's see. I feel like I have a real problem on sticking to a project, specifically when it's not work related, like some passion project I would like to push forward. Yeah, so that's the thing. Like, if maybe this will work for you and maybe it won't, right? But if you apply those things that we just talked about, maybe that'll help you. For me, it's like once you get past a certain point, there's also the sunk cost fallacy, right? Where you've already put so much into it, so it would suck to abandon it at that point. There is that too, All right. Let me find somebody to raid. And while I'm doing that, I just want to say thank you guys very much for joining me here. You guys have been awesome. I appreciate you guys. And if you haven't already, I would greatly appreciate a follow on the Twitch side or the YouTube side, or if you're so inclined, both would help me out immensely. My whole goal with this also is to get people into the industry, and get people into game engine development, because I think we need more competition in this space. And so I think the more people that are driven into this, the more competition that we have, the better, because that tends to drive ingenuity. And I think that that's always a really good thing. So, yeah, that's kind of the end of my spiel there. Let's see. Just looking for somebody to raid. Bear with me just a moment here. Let's go with I'm trying to find something that's kind of related, but that's actually a little bit of a challenge tonight. I don't know that we're going to actually find anything that's kind of super related to what we're doing here. So I think, thank you for the sub over on the YouTube side. Appreciate that. Yeah, okay. We are going to raid my buddy over at Hypnotic Games. I'm going to see what he's up to. And thank you guys so much for being here. I appreciate you guys, and I will see you guys on the next stream. And I'll go ahead and also shoot you guys over on the YouTube side a link to this Twitch stream if you guys want to check that out as well. But yeah, that's going to do it for tonight. See you guys later.